There is an interesting and I think important divide in big data. On one side, we have big data that represents collected information from an authority. On the other side, we have big data that has been measured or recorded from the real world. I think of the gun sales visualization and of the migration visualization when I think of collected information. Think of tweets, power grid utilization for my own project, and hospital patient records when I think of measured and recorded information. The point of this distinction gets to the purpose of the class and the purpose of big data. We care about big data and how we see it because we care about how big data can empower individuals to make informed decisions. This is where I really like the physically measured data. It strikes upon a reality that can be tested and analyzed. Let's take, for example, the hospital data. Yes, it's big data, and yes, it's cool that we can visualize it, but the important thing is that you can improve the effectiveness of the hospital. That's what matters, not how cool the visualization is. We can take this a step farther than just patient records, which can still be wrong. We have seen several examples in projects and course videos related to sports. While I realize that sports are not as important as patients in hospitals, I think the lessons from big data in sports can help us more broadly. Chris's last video describes the use of big data in Formula One racing. I think it's really cool that you can use engine data to determine how to tune a race car. I think, though, that we can extend this idea. Why not use big data to find ways of making cars safer? Can we put something like a black box into a car that will track all details of a crash and then re-engineer new cars based upon that? Alternatively, can we use big data to make engines more efficient? Can we customize algorithms for fuel economy based upon how my engine actually performs in the real world, based upon how I drive in the conditions I drive in? In my visualization presentation today, I will talk about Major League Baseball's Pitch FX system. It tracks all pitches thrown in the big leagues, in all parks, in all games. What if we could apply the same idea to take a baseline of a person's physical movements so that as age takes its toll, we can create customized joints to enable them to move better? I believe that this is the future of big data and the future of computing, real-world measurements driving individual solutions.